Today we're going to be talking about how to factor a sum and difference of cubes. But before we do that, let's take a look at this pattern right here. 1, 8, 27, 64. What's going on here with this pattern? Is it plus 7? It's not plus 7 because this isn't plus 7. It's not times 8. So what's going on here is that these are your perfect cubes. So 1 cubed is going to come out 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. So we're going to keep going here. 5 cubed is going to be 125. 6 cubed is going to be 216. 7 cubed is going to be 343. And 8 cubed is going to be 512. So these numbers in this pattern, because they come from a cube, are called perfect cubes. So if we're going to be factoring a sum or difference of cubes, we're going to have to look out for our perfect cubes. So these are numbers that we're going to want to know. 1, 8, 27, 64, 125, 216, 343, 512. Now obviously there's more perfect cubes than this, but we're usually going to stay within this range of perfect cubes when we do this. So here is the pattern for factoring a sum and difference of cubes. First of all, in order to do this, you need to have a binomial, 2 terms, where each term is a perfect cube. So in this case, we had a cubed plus b cubed, which is the same as saying a has been cubed and b has been cubed. So how this factors is the first parenthesis kind of matches up to what the original was after I write them as cubes. So a plus b. In the next parenthesis, we're going to get the first term squared, the 2 terms multiplied in the middle, and then the last term squared. Now check out the order of the signs. When this is a plus sign, the first parenthesis will have the same exact sign. The next parenthesis in the second parenthesis will be opposite, and the last sign will always be positive. Now check it out for when it's a difference. It's the same pattern. You're going to have a minus here, so the first parenthesis is going to be exactly the same. The second sign is going to be opposite, and the third sign is going to be always positive. One way to keep that straight is an acronym, SOAP. That's going to be the same, the opposite, and always positive, SOAP. So let's try this in action. Here we have a binomial. Now notice from our list above, 27 and 8 are perfect cubes, so I already have an idea that I might be factoring this as a sum of cubes because it's a plus. So the first question I'd ask myself is, can I write 27x cubed as something cubed? So 3 cubed would be 27, and x cubed would be x cubed. So 27x cubed is the same as saying 3x cubed. Let's move on to the 8. What cubed is 8? Well, 2 cubed is 8. Now let's remember what our pattern is here. So now I have it in this form here. So the first parenthesis is going to basically match up to this. So when I'm factoring this here, I'm going to get, in the first parenthesis, 3x plus 2. And remember, the first sign will always be the same. So now in the second parenthesis, I want to take the first term, 3x, and square it. So I'm going to square the 3, square the x, and get 9x squared. This next sign will be the opposite of the sign in the first parenthesis. So this is a plus, this will be a minus. Then I multiply a and b in the middle. So in the middle here, I want to multiply 3x times 2. That's 6x. And the last term will be the second term squared. And remember, this last sign is always positive, and the reason why it is because you're squaring a number to get here. So now I've factored this as a sum of cubes. This second parenthesis will never factor any further when you use this method. So let's try another one down here. x cubed minus 1. It's a binomial. These are both perfect cubes. I could rewrite this as x cubed minus 1 cubed. And so when this factors, the first parenthesis will match up. The second parenthesis, I'm going to square the first term, so I get x squared. The opposite sign, so a plus. Multiply these in the middle. Now remember, we're going to ignore this negative because we already took care of the sign. So x times 1 would just be x. And then square the last term. So plus 1. And now I've factored, this time, a difference of cubes. Let's move on to the next one. So this one, remember the first step when you factor is to look for a GCF. So 2 and 16 are not perfect cubes, but they do have a 2 in common, so I can factor those out. Let's factor that 2 out, and I'm left with x cubed minus 8. Now that 2 is just going to hang out outside until we finish factoring this x cubed minus 8. Now when you look at this, this is a difference of cubes. X cubed is a perfect cube, and 8's a perfect cube. So what we're going to do here is rewrite this as x cubed, and then what cubed is 8 is 2. So this is going to equal, don't forget that GCF on the outside. The first parenthesis is going to match up perfectly, x minus 2. The second parenthesis, I'm going to square the first term, x squared. Let's remember SOAP. So same, this will be opposite. Multiply these in the middle, you get 2x. And then square this last term plus 4. And now I have this completely factored. So what I want you right now is to pause the video and see if you can factor 27x cubed plus 1. Now that you've had a chance to practice this, let's see how you did. So here we have 3x to the third plus 1 to the third. So when this factors, the first parenthesis is going to be the same, 3x plus 1. In the second parenthesis, we're going to square the first term. Make sure you square the 3 as well. We're going to get 9x squared. And then we're going to multiply these in the middle, but remember, this sign is the opposite. So we're going to get minus 3x. And then square the last term, plus 1. And now we have this completely factored. Now remember, this last one looks a little scarier because there's exponents on the variable, but it's actually easy because how do you tell if a variable is a perfect cube? If its exponent's divisible by 3. So on this one here, we can take xy squared to the third power. The reason why that works is because if I multiply these back by 3, I'd get this. So just divide the exponents by 3. And if one of these wasn't a multiple of 3, then it couldn't be a perfect cube. 64 is a perfect cube. That is 4 cubed. So our first parenthesis is going to match up exactly. Same sign. Minus 4. Now when we square this here, square the x, I get x squared. Square the y squared, I get y to the fourth. Then we're going to get that opposite sign here. Multiply these in the middle, I get 4x y squared. And then square the last term, always positive, so plus 16. So let's have you try one and then bring it to class tomorrow, and we'll check in to see if you get this. I want you to factor 64 x to the 9th minus 125. Factor that in your notebook and bring it to class tomorrow.